So hello everyone. So today we will talk about root and ratio test. In the last session we talked about comparison test, namely direct comparison test and limit comparison test. Today we will going to talk about ratio test and root test. So what does the ratio and root test tells us? So let's see the ratio test first. What does it say? So if you have a series with the terms of an as strictly greater than 0 and you take this limit of an plus 1 upon an. So here you can see that we are dividing by the terms of the series. That's why we need non-zero. So we find this limit and let's call this limit as rho. Okay, and what does the root test says? I mean, it's not complete yet. They both gives the same conclusion. So I'm just stating the main part. So what does the root test says? If you have a series with an greater equal 0, here you can have equal to, because what is my rho over here? It is the nth root of an. So you take the nth root of an and you take the limit n going to infinity. You call that as rho, and here my rho is what? In ratio test, the rho is the limit of an plus 1 upon an. In root test, my rho is nothing but nth root of an. Then what does both the tests conclude? That if your rho, in both the cases where your rho is less than 1, then your series converges. If your rho is greater than 1, then the series diverges. And if rho comes out to be 1, in either case, here also and here also, if the rho comes out to be 1, then the test is inconclusive. That means you cannot conclude anything. So this is what your root and ratio test says. If the limit of the ratio an plus 1 upon an is rho, and if rho is less than 1, greater than 1 or equal to 1, then the series converges, diverges and inconclusive respectively. And same for the root test. So let's see some of the examples. So see, I mean, like comparison test, if you observe, there you had ans and then you found bns. So that was one of the critical part in comparison test, that ans will be given to you, it will be your job to choose bn. Whereas in root and ratio test, we have that plus point. Here we are only playing with the given series. We are not bringing into picture the another series. So you have to only play with the ans and then you have to conclude. So this is the plus point of root and ratio test, that no need to think of the new series. Whereas that we can say it's a negative point of comparison test. But then what is the plus point? Once you choose your bn in comparison test, your job becomes pretty much easy. Whereas here, if rho comes out to be 1, which happens many times, then the test fails. So both has its pros and cons, but yeah, we will use the test whichever is beneficial to us. So let's take some examples so that the test will be much more clear. So suppose if I take the first example as summation 2 raised to n upon n factorial. So whenever you say factorial, so if you remember my comparison test, the tricks which I told you during the comparison test, you throw away constant terms, logarithm, exponential, trigonometry terms. But here none of the things are coming into picture. So here you are having factorial. So my suggestion is, whenever you see factorial into the picture, you always prefer ratio test. So here what are my ans? My an is nothing but 2 upon n factorial. What will be my an plus 1? It will be 2 upon n plus 1 factorial. So if you take limit n going to infinity, you take an plus 1 upon an. Don't interchange, don't take an upon an plus 1. What do I get? 2 upon n plus 1 factorial whole divided by 2 upon n factorial, which is nothing but n factorial upon 2. 2 goes away. N plus 1 factorial is nothing but n plus 1 into n factorial. So I'm only left with n plus 1. And when n goes to infinity, this is nothing but 0. So my rho is what? 0, which is obviously less than 1, and therefore by ratio test, the given series is a convergent series. So I hope this example is clear. If you take one more example, suppose if I take summation, let's take one more example. If you take summation n raised to 4 upon 4 raised to n, I want to see whether the series is a convergent or a divergent series. So here also ratio will be much more preferable, because you don't know which terms to throw away. So Like this you can think, okay, if I want to use comparison, there is no constant term, there is no exponential, log or trigonometry terms, so I cannot throw away anything. So it is difficult to choose your Bn. So therefore you try for ratio test. So here my An is what? An is n raised to 4 upon 4 raised to n. Your An plus 1 is what? N plus 1 raised to 4 upon 4 raised to n plus 1. Now you take limit n going to infinity, An plus 1 upon An. So what you get? Limit n going to infinity. What is An plus 1? N plus 1 raised to 4 upon 4 raised to n plus 1 whole divided by n raised to 4 upon 4 raised to n. And if you try to solve this, this is nothing but limit n going to infinity, n plus 1 raised to 4 upon n raised to 4 into 4 raised to n goes away, what is left is 1 by 4. And as n goes to infinity, this is nothing but if you take n inside, limit n going to infinity, 1 plus 1 by n raised to 4 into 1 by 4, and this is nothing but 1 by 4, which is less than 1. Because this 1 by n, this goes to 0, I can take this limit inside the fourth power. Why so? Because of the continuity theorem. If you recall our theorem which we saw in sequences, that if you have the power or square root or logarithms, then you can take this limit inside. If you don't remember this theorem, my suggestion is you please go through that theorem of continuity, which you will find in the playlist of sequences. And because of that, I can take this limit inside, and then 1 by n goes to 0, this is 1, so I get 1 by 4, which is less than 1. Therefore by ratio test the series converges. So this is how a ratio test helps us to solve the problems. Actually it's not compulsory that you have to use ratio test. For this example, even root test will help you. So how does root test will help you? So if I want to solve this example by root test, so what I will do, you take limit n going to infinity, you take nth root of an, which is what? Which is nothing but limit n going to infinity. What is nth root of an? N raised to 4 upon 4 raised to n raised to 1 by n. This is nothing but limit n going to infinity, n raised to 1 by n, 4 upon 4. And there is a result that limit n going to infinity, n raised to 1 by n is always 1. So as n, you can use this result. So this is nothing but 1 as n goes to infinity. So I am left with 1 raised to 4 upon 4, which is 1 by 4, which is less than 1. So again by root test the series converges. So it's not like you have to only use ratio test. Sometimes you can apply multiple tests to a given series. So you have to choose the series which you want and wherever it is applicable. So if I take one more example, suppose if I take, so whenever you see power into the picture, my suggestion is you prefer root test. Whenever you see the power of n in the picture, my suggestion is you always use the root test. So for example, if I take summation 1 minus 1 by n raised to n square. So I want to find what is the nature of the series. So here if you try to apply ratio test, here it will be 1 minus 1 upon n, what will be an plus 1? 1 minus 1 upon n plus 1 raised to n plus 1 square, which is, you can see, it's not a good term. So we will avoid ratio test, or another way is, since there is a power of n in the picture, we will prefer root test. So what does the root test tells you? You take limit n going to infinity, nth root of an. What is my an? This is my an. 1 minus 1 by n raised to n square. And what is this? This is limit n going to infinity, 1 minus 1 by n raised to n. You have n square and 1 by n, so you have n. And if you remember, we saw that where does this sequence converges? One of the lecture in sequences playlist, you will observe that this is converges to e raised to minus 1. We proved in sequences that 1 plus x by n raised to n goes to e raised to x. Here x is minus 1 and this is nothing but 1 by e, which is less than 1. So therefore by root test, since the nth root of limit of the nth root of an is coming out to be less than 1, therefore the given series converges. So that's how you can use root test to answer the question if the power contains n. If I want to take some more example, so again if you take, say, summation ln of n raised to n upon n raised to n. Now again here, if I can see there is a power in the picture, so I will prefer root test. So what you do by root test, what do you have? Limit n going to infinity, ln of n upon n, this whole n, and you take what? You take the nth root of an. We take the nth root of an. So here this nn goes away. So what I am left with, limit n going to infinity, ln of n upon n. As n goes to infinity, this is infinity by infinity form. So we saw in sequences L'Hopital rule. If I use L'Hopital rule, limit of this sequence is nothing but 1 by n upon 1, which is nothing but 0, which is less than 1. So again, the by root test, since the ratio, the limit is coming out to be 0, which is less than 1, therefore again by root test the given series converges. So that's how you use the root and the ratio test. So these are the basic, you will say 4 basic tests which are used in series. So which were the 4? In the previous test we saw direct and limit. Direct and limit comparison test, and today we saw ratio and root test. So when do you use direct or limit comparison test? Whenever you see constants or exponential or log, or you can say trigonometry. Whenever you see these terms in the series, you try to throw away this term and see what is left, and then choose that as your bn's. Many times that bn will work. If that doesn't work, try to modify that bn. Which bn? The bn which you got after eliminating these constants, exponential, logarithm, trigonometry. So that bn will work most of the times, and then you can apply direct or limit comparison test. Okay, so whatever bn you have got, if you are able to compare with an, then use direct comparison, and if you don't know which one is bigger or which one is smaller, apply limit comparison test. So this is the scenario when you can use direct or limit comparison test. And whenever you see factorial or you see nth power in an, means if these are the things there in the series, then my suggestion will be you apply root or the ratio test. Factorial, so mostly you prefer ratio test, and nth power, then sometimes both will work or sometimes only the root test will work. So right, this is not the golden rule I'm saying. Okay, so this is not the golden rule, this is just the suggestion that if you use these tricks, then this will be useful many times. So these are the 4 tests which helps you to determine the nature of the series. And in all the 4 tests, if you have realized, what was the condition? The condition was all the terms of the series should be either strictly greater than 0 or greater or equal 0. That means all the 4 tests are only applicable for positive or the non-negative terms of the series. So if you have all the terms positive, if you have all the terms positive, or if all the terms are negative, then you can apply the test. All the terms are positive, no problem. If all the terms are negative, you take out minus sign outside. And now all the terms are positive, so you can apply your test, direct comparison, limit comparison, root or ratio, and then whatever the nature of the series will be this. If this is convergent, multiplying by -1 doesn't change the nature of the series. We saw the arithmetic operation on series, right? So in there we saw if a series is convergent, its scalar multiplication is also convergent. Therefore this will be convergent. And if this is divergent, then its non-zero multiple is again a divergent series, so this will be divergent. So if all the terms are positive, no problem. If all the terms are negative, you can take out minus sign outside, so that all the terms will be positive inside, and then you can apply any of the 4 tests you want, and at the end you multiply by -1 and you can conclude the nature of the series. So this is how you can deal with the series if it has all the positive terms or if it has all the negative terms. In the next lecture we will see how to deal with those series where we are having alternate signs, that means plus minus or minus plus minus plus. So I hope this is clear. If you have any doubt, you can comment in the comment section. Thank you.